Precalculus, we move on to section 7.6. This will be the last one. So we will be having a test shortly on another half test on sections 4, 5, and 6. And if you think all the way back to beginning of chapter 7, you should say, you know what, Larson, solid move. Thank you for the 2 tests on chapter 7. Anyway, this would be the double angle and the half angle formulas. Let's put a 2 theta up there for double angle and theta over 2 for a half angle, and we should put a day 1 here because I forgot to type it. My bad. If theta is an angle, then the double angle would be 2 theta, and half of that angle would be theta over 2. We're going to come up with identities for those 2 things and use them to find new angles and establish new identities. Blah-diddy, blah, blah, blah. Here we go. Recall the following 3 identities. The sine of a plus b. We got this one 2 days ago. It goes like this. The sine of a times the cosine of b. We keep the same sign as we were given, and then we go the cosine of the first one, a, and the sine of the second one, b. That is the identity for sine of a plus b. I think I gave them as u and v the other day. Sometimes it's alpha and beta. It really doesn't matter what the angles are. It's the pattern. Cosine is different. Cosine goes cosine of a, cosine of b. And then the sign switches, and then it goes sine of a, sine of b second. All right, and then tangent, it gets more space because there's a stupid fraction. Everybody hates tangent. It's the tangent of a plus the tangent of b. The numerator gets the same sign as the parentheses. The denominator gets the opposite. So it goes 1 minus tangent of a times the tangent of b. We're going to use those 3 identities that you learned a couple days ago to come up with something new. Here's the sine of the double angle, the cosine of the double angle, and the tangent of the double angle. Well, I can think of 2a like this. Sine of, ready for this? I know you can't see it because I'm writing. Just wait for a second. The sine of a plus a. So I'm going to do the same thing. I'm just going to put the angle in there twice to represent 2a. So look, using that top thing, this will go the sine of the first one, a, and the cosine of the second one happens to be the same angle, a, and then a plus sign, and the cosine of a, and the sine of a. Oh, barely fit that in there. Sorry about that. Hey, now, even though these are in different order, it's the same thing. If you multiply 2 times 4 and 4 times 2, it's the same thing, right? So I can just write this as 2 times the sine of a and the cosine of a. The sine of 2a is 2 sine a cosine a. Okay, cosine of 2a. Well, that means the cosine of a plus a. Well, if I use that identity, it's the cosine of the first one and the cosine of the second one, which is also a, and then we switch over to minus, and it's the sine of a times the sine of the other one, which is also a. So what I get out of that is cosine of a times itself. That's cosine squared a, and then a minus sign, and sine squared a. Looks like the Pythagorean identity, but it's not because it doesn't have a plus. It's got a minus instead. And then, of course, tangent's got to have more space because it's a fraction. Here we go. The tangent of a plus a goes like this. In the numerator, we add them. Tangent of a plus the tangent of a. And the denominator goes 1 minus the tangent of a times the tangent of a. So what do I end up with? 2 of these on top, 2 tangent a. On the bottom, 1 minus tangent times itself, so 1 minus tangent squared a. So there you go. We have 3 brand new identities for you today. The sine of 2a is 2 sine a cosine a. The cosine of 2a is cosine squared minus sine squared. And the tangent of 2a is 2 tangent a over 1 minus tangent squared a. Now let's turn the page and go to the next page. And what do we got? There's some examples. Let's do something with them. So go to the next video and we'll do some examples.